Hello students, welcome you all in class 10. Now, without wasting much time, let's start our first topic of math. That is, our first chapter is real number. See students, we should not waste that much time in explaining real number because we have already studied in class 9 real number, what is real number, then natural number, whole number, integers, rational number, irrational numbers. We all have idea about all these things. In this chapter, our first topic is, or you can say our first main topic is Euclid division lemma and fundamental theorem of arithmetic. Before explaining Euclid division lemma, we should know what is lemma. So student, a lemma is a proven statement used for proving another statement. What I said, it is a proven statement that is used for proving another statement. So there is no need to prove lemma. That is already a proven statement and we will use. Now see, our main topic is Euclid division lemma. So, what is Euclid division lemma? For that we should know for given positive integers. You have idea about integers. What are integers? So, for given positive integers a and b, there exist unique integers q and r. What I said, for given positive integers a and b, there exist unique integers q and r satisfying a is equals to bq plus r. Here r is less than or equal to 0 or r is less than b. Now see, after seeing a is equals to bq plus r, do you observe something? Dividend is equals to divisor into quotient plus remainder. See, a is equals to bq plus r. So, here a is dividend, b is what? Divisor, q is quotient and r is our remainder. So, that is we can write dividend is equals to divisor into quotient plus remainder. For example, just you divide 5 by 3, you get 1 as quotient, 2 as remainder. So using Euclid division lemma, what it is said, a is equals to bq plus r. So here dividend is equals to divisor into quotient plus remainder. So you can say this is the way. This is the way how to write in Euclid division lemma form. So here we have seen that we state Euclid division algorithm for positive integers only. When we can explain Euclid division algorithm, we can explain for positive integers only, but it can be extended for all integers except 0. So we can say that b should not be equals to 0. Is that clear? Now you see, when a and b are two positive integers such that a is equals to bq plus r and you have to see r is less than equal to 0 or less than b, then HCF of ab is equals to HCF b and r. Now see, there are certain steps how to follow Euclid division lemma. Your question will be, using Euclid algorithm, find the HCF of 240 and 228. Here I have used 240 and 228. You can use other also. See, for this, first what you do, just in rough, you divide. You find the you write in that way 228 240, you divide in that way and you write in a rough part so that it will be easier for you while writing. Now you know the formula, a is equals to bq plus r, dividend is equals to divisor into quotient plus remainder. So you already know that. So you divide bigger number by smaller number. So here you have seen that here I have divided 240 with 228. I got the remainder as quotient as 1 and remainder as 12. Accordingly, I have divided and got here remainder 0. So now see, the main thing, the pattern you should follow is how you have to write in Euclid division lemma form. Here 240. So 240 dividend is equals to divisor into quotient. So here our divisor is 228. Quotient is 1. Dividend is equals to divisor into quotient and remainder is 12. Now again you have to write 228 is equals to, after dividing 12 into 19 plus 0. So here you got the remainder as 0. So HCF of 240 and 220 is equals to how much? 12. Now see, this is the example I have given. And now what are the steps? What steps we should follow in that? Let two integers be a and b, as you have seen in examples 240 and 228. Take greater number a as dividend and the number b as divisor. Now find whole numbers q and r as quotient and remainder respectively. Therefore a is equals to bq plus r, and here r is less than equals to 0, and see here, if r is equals to 0, b is the HCF of a and b. When you find r is equals to 0, then HCF will be HCF of a and b is the HCF of a and b. If r is not equals to 0, then again you divide and find the divisor and dividend. Repeat the step till you get 0. So at the last step, your required is obtained 0. The divisor thus obtained at this stage is the required HCF. You just try, practice it. Wherever you face problem, please you contact me in between 2 to 4 p.m. Till then, thank you.